Now let's just see another example or another question which says that prove that root 3 is an irrational number. Now we have to prove that again square root 3 is an irrational number. So let's just start the solution set of this particular question by the method of contradiction. So let us suppose I am writing by contradiction first of all. By contradiction we are proving the solution of this particular question. So suppose that by contradiction we are saying let if square root 3 is not an irrational number. It is not an irrational number. So if square root 3 is not an irrational number, then it implies that square root 3 is a rational number. It is nothing but a rational number. So by the definition of rational number, what we can say? By the definition of a rational number, we can express square root 3 as of the form a by b. We can express it in the form of a by b. So let us suppose we are expressing it in the form of a by b, but with a condition that the highest common factor of a and b is nothing but 1, or we can say they are nothing but co-prime. So let us suppose I am calling this as equation number 1, and again I am multiplying b with the root 3. So we get the answer as a is equal to root 3 into b. Again I am taking the square on both sides. So squaring both sides, after squaring both sides, what we get the answer as a square, which is equal to square root 3b whole square. So after squaring it, we get the answer as 3b square. So it means that a square is equal to 3b square, and we can also write it as a square by 3, which is equal to b square. We can also write it in this particular formation. So let us suppose I am calling this as equation number 2. Let us suppose I am calling this as equation number 2, and I am calling this as equation number 3. So from the equation number 3, what we can say? We can say that 3 divides a square. 3 divides a square from equation number 3. Being 3 a prime number, we can again use the same result or the same theorem. The same result or the same theorem says that if a prime p divides the square of the number, then it divides the number a also. So using this particular result, or we can say using this particular theorem, what we can say? We can say that if 3 divides a square, it implies 3 divides a. So using this particular result, so let us suppose I am saying using the result, we can write 3. If 3 divides a square, then it definitely divides the number a. So it implies that if 3 is dividing a, then we can express it in the form of a by 3, which is equal to some c, being c an integer, c being any integer. So let us suppose we are taking c being any integer. We can express it in the form like this. So let us suppose we can write it in the formation of a is equal to 3c. Let if I am calling this particular equation as equation number, let us suppose I am calling this equation as equation number 4. 3 divides a as equation number 4. Let us suppose I am calling it as equation number 5. So substitute equation number 5 in from the equation number 2, if we'll substitute the value a as 3c over here, we will get the answer as 3c whole square, which is equal to 3b square. Let's just solve it. We get the answer as 9c square, which is equal to 3b square. Now cancel out the common values over here. We get the answer as 3. 1 is 3. 3 into 3 is 9. So it will be like nothing but 3c square, which is equal to b square. And now we can express it in the form of, b square by 3, which is equal to c square. We can express it in the form like this. And from this particular equation, let us suppose I'm calling this equation as equation number 6. From the equation number 6, we can say that 3 divides b square. From the equation number 6, we can say 3 divides b square. Again, if 3 divides the square of a number, then 3 divides the number itself. 3 divides b by using the result. By using the result, we can say if it is dividing this particular square, then it divides the number itself. So let us suppose I'm calling this particular equation as equation number 7. So again, from equation number 4 and 7, what we can conclude? We can conclude that 3 divides a as well as b. So it means that 3 is a factor of a and b. It implies, it is again a contradiction. It is a contradiction to our supposition. It is a contradiction to our supposition that square root 3 is a rational number, because we know that the only common factor of a and b was 1, but here we are getting the factor of a and b is 3. So it means that it is a contradiction to our assumption, which implies that square root 3 is an irrational number, hence proved. So this is nothing but the proof of square root 3 is an irrational number. So using this particular result, we can prove that with the help of the method of contradiction, that how the number square root 2, square root 3 or any kind of an irrational number is irrational. I hope all the steps are all clear to you. So let's just try out another example to get more clarity.